So we've seen how to clone and link a Teams repo so that we can make use of common team parts. We're going to add a part to our Teams repo, set it up all correctly, and then make a pull request so that we can share it with the teams in a safe and scalable way. Here's the part that we're going to work with. This is a pretty unusual part. It's a DC to DC converter. It's got this custom footprint of this very strange package, and we want to capture all of our hard work and put it into the Teams repo. I've already managed to download this part in 3 files. So I have the symbol library. So this has actually come as a pre-baked symbol library. I think I got this from Snap EDA. So we're going to extract it from that library and put it into the Teams library. We have a footprint file already made, and we also have a 3D model. And I found this separately. I think I just Googled SpanO2 CAD to find it. So I've kind of pieced together these 3 files or made them myself. In any case, we're going to add them to the Teams repo. It's always a good idea to do a fetch. Just make sure there are no pending updates. Yep, we're up to date. I'm going to create a new branch for my changes. I'm just going to start by creating a new branch called Feature SpanO2. This is a pretty common way to designate branches. Have some predefined keyword and then the project you're working on. So here we're working on a new feature. It's the SpanO2. Or you could say, maybe you want to adopt the new part tag. Well, we'll just start with new part SpanO2. That'll do. And we are now on the new branch, and we could publish this branch to GitHub if we wish, but first I'll make the change. So I'll open my repo folder from GitHub. And I'll copy in my 3 files. We don't necessarily want to keep this symbol file. I'm just going to put it in here for now, and then I'll delete it. The loop will close in a sec because we're going to extract the footprint out of that library. So here's my 3 files in the repo, and we ought to be able to see, yes, there are now 3 changes that we could stage for committing. But we'll just do some housekeeping first. In the symbol editor, I'm going to temporarily add that span library. Here's our new Teams library. I'm just going to add a new global, and that is the library that I downloaded for the part. So that's now added to our global libraries. That's one awkward thing about KiCad, is that all the symbols are always inside a library. So here's the SpanO2A TAC12 library. Here's the part. Beautiful. I'm going to right-click, copy this symbol, and I'm going to paste it into my Teams library. If you've made your own symbol, you won't have to do this step. This is just a little awkward because I've downloaded this. But I can make sure I commit that save. And now I'm just going to do some housekeeping and remove that temporary library. While I'm at it, I'll also take this moment to remove it from the repo because I don't want to commit the new library. I just want to modify my existing Teams library. Footprints are a little simpler though because they're just individual files. So I'm going to pre-associate this symbol with the appropriate footprint. Go to File, Symbol Properties, and we'll associate the footprint. We're in the new Teams KiCad library and it's already enumerated that SpanO2 footprint. Beautiful. So we've pre-associated our footprint. And the final step is to pre-associate the CAD. In the footprint editor, I'll open my span footprint, go to File, Footprint Properties. We'll add a new entry, and rather than use these file navigation panes, I'll just grab the file name straight out of my directory because I know it's exactly where it's going to be. Strike enter, the model appears, and now we just need to position it correctly. Make sure my part is set up as a through hole for this correct part type. And save. Make sure your symbol is saved as well. Back in my Git application, we can see there are 4 files that have changes. We have our step file, very good. We have our footprint file, and we have our library file with an update. The great thing about KiCad is that everything is human readable text. So it works with Git surprisingly well. Everything is just changes to code, which is wonderful. Step files are a little different. We have this fourth file, which is just a backup file. I don't want to commit this. It would probably be prudent to set up this library with a git ignore file that will ignore all these meta files that KiCad can generate. I'll leave a link in the static content for further resources on that. In any case, I want to remove or uncheck this file. I don't want to stage that for committing. So we have our 3 files, and all I'm going to add as my commit message is add span02 component. I can include some more details and I'll create the commit. After completing the commit, I will publish this branch to GitHub. Now when I return to GitHub, I can compare and create a pull request for my new part branch. This is going to create a request to merge my branch onto the main branch. The main branch is like the distribution branch. Avoid committing to main as much as you can. It's more orthogonal and scalable, especially in teams, if you create branches for your projects. In this case, the project is a new part. We can add some comments. We can have some conversations with pull requests. So this isn't like the point of no return by any means. There's never a point of no return in Git in general. So I'm just going to create that pull request. Now, if I weren't a maintainer of this repo, then this is where a maintainer of the repo would come in, we would have a discussion, they would review the changes, and if they're happy with it, they would merge the pull requests. If you're a maintainer of the repo, you can execute it on the spot. But in any case, we could have a discussion, they could suggest changes, and there's even like potential to just cherry pick small changes. So it's a very powerful system. But in any case, I'm just going to leave this as is and wait for a review. And another maintainer of the repo and I can have a chat, and then we can execute the merge.